Hello, welcome back. I'm Jeff Stukenborg. I'm the Reman Engineering Leader for the ZF Group and also the Chairman of RIC. So if you were hopefully with us early on when we had our first speaker, and now we're to our first panel discussion, which is going to be on remanufacturing of the electric vehicle. So just a few housekeeping notes is at the end on the side in your comments, you'll have a place to put in questions. So toward the end of our conversation, feel free to add questions and we'll go through those questions. After the session, there'll be a quick survey that will appear on your screen. Please take a moment to provide your feedback. It helps us to improve our experience. If you're going to go ahead and continue this conversation on Twitter, please make sure to mention us at the @WorldReman. And then to access all the features available through our virtual conference platform, to hop in, be sure to download the app for both Apple and Android users. There's things in there that you can also see. And then finally, this session will be recorded and it will be sent to you after the conference. So with that, I'd like to prime our conversation with a short presentation that based on an article published by Nature and some other industries, just to kind of help set the stage for our four panelists. Go ahead and go to slide 2. So you can see here on the forecast of the passenger cars, you can see that going electric, there's a major increase in the penetration of electric vehicles versus internal combustion engines. In fact, this chart shows that by 2035, that 50% of the new vehicles built will be electric, and then the other 50% will be internal combustion engines. That's kind of helped by legislation, regulations, interest in the zero emissions and circular economy, but also much helped by the plummeting cost of batteries, as you can see on the right. Next slide, please. So when we look at the difference between internal combustion engine vehicles and battery electric vehicles, the one on the left, you can see the different powertrain components. So when you're comparing the internal combustions going to electric vehicles, some components are new, some are completely omitted, and then some just kind of changed in the system itself. And you can see how this is kind of shown. So those in orange on the left don't exist on a battery electric vehicle. Those that are in green kind of change their systems a little bit depending on the design. And then on the right, you can see all the blue dots, all of those that are brand new now in a battery electric vehicle. There's some hints by the dollar signs added on the right about the cost of each of these components. The reason we talk about this is I think it's going to have a lot to do about in our panel discussion. You're going to looking at what the opportunities are in the remanufacturing, repurposing, and recycling world are going to have probably a lot to do with the actual value of those individual components. And then the next slide. So as you look at basically the life cycle of an EV battery, the first life cycle is, of course, on the vehicle. And what I think we see is that battery is going to be on a vehicle for maybe 7 to 10 years. But even after that 10 years, it still has a lot of capacity left. And the question is, so what do we do with it? Well, they're going to be collected, right? Just like leaded batteries are today, are fully recycled, they're going to be collecting these batteries. There's going to be opportunities in the remanufacturing world where they can look at let's say a pack level and maybe some repair of the cells. That's a more difficult. But try to get these things back to maybe a little bit improved life. And then maybe the second option would be the reuse. And then now we're looking at more like secondary applications, maybe stationary power grids, things like that. We're going to talk more about that in our panel. And then finally, the final is really the life cycle is just pure recycle. There's a lot of valuable materials in these. Some of them are very expensive, some are very hard to find. And recycling is going to be an important part of the final option. So I'd like to go ahead and the next slide introduce my panel members. So Mark Phillips is the editor and video host of Aftermarket Intel, a media outlet that covers the global aftermarket technology and auto parts industry. Mark has spent more than 13 years as an automotive aftermarket editor and video host, and more than 26 years as a journalist. He received an automotive aftermarket professional certification in 2012. Don Hildebrand was named one of the 100 most influential people bringing about the electrification of the automobile by Automotive News. and is on the Forbes 10 list of automotive thought leaders. He's a director of Argonne National Laboratory, Energy Systems Division. David Maxwell is a battery technical specialist with BorgWarner, a 130-year-old company delivering innovative and sustainable mobility solutions for the vehicle market. Based in Detroit, David previously was a battery second use engineer and a battery controls engineer at General Motors. And finally, Eric Lundgren is a social entrepreneur and an innovator. He's the CEO of Big Battery Inc., the largest supplier of surplus batteries in the United States, specializing in new cost-effective energy solutions. He is also the founder of IT Assets Partners. Eric's life's purpose is to create a sustainable energy and recycling solutions in the world. So I'd like to go ahead and bring up my panelists. And what I'm going to do is give them an opportunity to kind of help talk a little bit more about themselves. And I'd like to start with Mark.
Thanks, Jeff. I'm Mark Lupes. My publication is Aftermarket Intel, and what I do is inform C-level executives and business owners who operate within the automotive aftermarket. So as a journalist, I'm an observer. The gentlemen I'm with today are the real experts. I like to think that I'm an expert in observing. I'm really interested in how the automotive aftermarket that I've been a part of for 13 years is going to make that transition from ICE engines to EVs. And I go to a lot of shows around the world, automotive shows, and I just got back from IAA in Munich in Germany, and there weren't any ICE engines at the show. They were all EV. So it felt like suddenly the entire world is now electric. So there's definitely a feeling, in the stats that Jeff showed bear that out, that electric is arriving a lot faster than we think. And like I said, I'm very interested in how the automotive aftermarket is going to make that transition. So I'm glad to be here today, and thank you for having me.
Go ahead, Don.
Yeah, thanks for the opportunity to be here as well. I'm Don Hildebrand, and I work for Argonne National Lab, one of the national labs focused on broad national research. I run the Energy Systems Division, which is focused on transportation and transportation technologies, the grid and grid modeling, and the interaction between the grid and vehicles, and then also the analysis of a lot of these large scoping transportation activities. If you know about Argonne, you know that most of the batteries that are in the world right now probably came through our lab. We're the lab that does battery chemistry, one of the lead labs that does battery chemistry, especially the lithium chemistries. We're also responsible for electrification of the automobile, as well as other national labs. We have fast charge capability. We've got the world's largest stationary storage battery right now. We're using that with charging electric vehicles, and to understand how those protocols work. And right now we have the responsibility for what's called a resell. That's the government's responsibility for putting together the domestic lithium battery recycling ecosystem. So this is a several year-long project. We're just a couple of years into right now, where we're supposed to come up with a process by which we will determine what's the best way to recycle this wave of batteries that are coming at us. Is it reuse? Is it reprocessing? Is it remanufacturing? And what's the proper combination of all of those things? Because it's most important to us that we recognized almost 10 years ago the only way this functions correctly in terms of electrification is if we have a closed cycle within the United States where we can reclaim the materials from the batteries we have. So very exciting to be here. Looking forward to the conversations, and want to talk about some of our work in terms of what we've determined so far through our analysis of this activity.
Great, Don. Thank you very much. David, can you give your introduction?
Hi, folks. Thanks for having me today. So as Jeff mentioned, I started my career out at General Motors. So I've had my whole career kind of steeped in batteries, starting out with the controls and kind of very specific look into batteries. And through my career, I've really broadened that up. Secondary use was a really interesting. It was a bit of a side project, but it was a really good learning opportunity to see how the system works, how the potential for reuse could occur. Does it make sense economically, technically, so forth. So it was a really great experience. I also worked at A123 for a little bit, just again, as an application engineer, continuing to broaden the level of breadth on battery systems, because I think as we'll probably get into, it's not just cells. It's the whole system. There's a lot of different components and aspects to a battery system, and I've kind of spent my career really broadening that out. And this is a really interesting area for me because it touches all those areas. What are the chemistry of the battery, all the way to the glues and the fasteners that you use at the system level. So I'm really excited to join this team. It's a real good group of folks here. So thank you.
Thanks, David. And Eric, go ahead.
Hello, pleasure to be here at World Reman. Thank you for having me. My name is Eric Lundgren. I'm the CEO of Big Battery and BatteryEvo.com. I, for the last 16 years, have specialized in the repurposing and reuse of electronic components. It was in the e-waste realm, and now it's moved on into the electric vehicle realm, since an electric vehicle is nothing more than a big laptop, right? Bigger battery, same size screen. So we moved into that about 8 years ago. We have 2 facilities overseas, and through our processing, we processed 37,000 actual modules from the EV realm in the last 12 months. We see that growing at 300% in 2022. There are 2 hybrid recyclers in the United States that are actively processing material, and we are one of the 2. Some claims to fame: we built the world's longest range electric vehicle in the Guinness Book in 2017. It went almost 1,000 miles using all repurposed parts. It was made from all consumer electronics, recycled materials, and EV battery packs that were repurposed. We are now building the world's longest range golf cart and fastest electric boat using all repurposed parts, just to kind of show how the past can power our future. I believe that Second Life is the future, and we're building it today at Big Battery.
Awesome. Thanks, Eric. As you can see, we have a really good kind of wide range of expertise here, and I think we're going to have a really good panel discussion. I'd like to go ahead and start in the panels. I'll just remind the audience that feel free to add your comments, any questions you have in the comments field of this application. And just to start with the first question, so obviously with the forecasting rate of EVs introduced in the market, it's interesting that Mark went to this show and all there are is EVs, so it feels like we're at 100% already. Obviously we're not. So with this increase dramatically, right? And what do you think the major application opportunities? And when I'm talking about that is in that one screen I showed you the different products on the right. That could be it. I mean, we talk a lot about batteries, but I would, we're going to talk about batteries for sure. Are there any other opportunities for remanufacture, for reuse the batteries as well as the other components? And I'd like to maybe start with Don, maybe on your side.
Yeah, sure. So the opportunities for remanufacturing, there are a lot of different approaches we could take in terms of what we do with the batteries when they're at end of life. And I think Eric probably is very familiar with this. You can reprocess it. Basically, you can, you chip and shred it and turn it down into black liquor and use that hydroprocessing. You could use pyroprocessing, burn it up and turn it into powder, and then mine those powders and rebuild the battery from it. Or you can actually do direct recycling. And direct recycling has just so many advantages. As we've started to do analysis on this, there's almost twice the value to the battery if you actually don't try to render it down to its raw materials and bring it back up again. So there's a real opportunity when you look at this large number of batteries that are coming downstream in terms of determining the best ways to direct recycle it. Design it to be disassembled, design it so it can easily be reconstituted, and find other uses for it. All of those have substantial advantages environmentally, economically, and financially over taking the battery right down to its fundamental materials.
So David, Don just talked a lot about the recycling side from the OE side, as when you worked at either BorgWarner or General Motors, and I was involved with the EV1 way back, so old enough to remember that. And I remember my first drive in EV1 was, wow, this thing's really fun to drive, So it's always fun about it when you think EV is more environmental, but to be honest, everybody that drives in these EVs, they love the speed at the end of the day, performance. So what are your perspectives on the remanufacturing, refurbishing, or reuse side?
Yeah, I think it's absolutely critical for OEMs to be a part of that, for the circular economy to happen. You can take several strategies on your battery warranty. So let's just start there at the very first place. You can design these systems so they're essentially very large bricks that if something goes wrong, you're chipping out adhesives and epoxies to get to even individual modules, and it's basically a wash. You're going to repurpose. You're going to put in a whole new pack. Obviously, that's very costly. There's a lot of issues around that. Recycling. If it's hard to disassemble, it's going to be just as hard to recycle as well. So as you start to evaluate your strategy and look at the different options for taking those packs back in, you start to see, okay, if I break this down to a module, if I make this more easy to disassemble, now my warranty costs go down. Well, that same effort to make your own warranty costs go down are going to be the same efforts that make repurposing easier, that make second life easier, that make recycling easier. So having that conversation up front is going to be absolutely critical. And it's not just the OEs involved, it's the repurposers, it's the recyclers, it's the logistics coordinators, it's all of those folks. It's the cell manufacturers, because at the end of the day, when you take down, even if you do a hydro or a pyro, do you make a lithium hydroxide, a lithium carbonate? Do what materials are the outputs of that process? And those go all the way back to the refiners and the cathode active material manufacturers. So everyone has to play a part, and I think everyone's been pretty comfortable in saying, well, that's 5 years out, that's 8 years out. Well, now it's 4 years out. Next year it'll be 3 years out. So I think as people are starting to ramp up, they're really starting to take this seriously. And so that's why I'm quite hopeful, and I think this is a really good time to have this conversation.
Perfect. So Eric, you're the expert here on repurposing. You mentioned that, and I think I'm going to go back into the design for reman and refurbishing and recycling later on, because I think that's an interesting cycle, because I know there's a lot of different technologies and maybe we're going to more commonize. But so Eric, from your standpoint on the reuse side of it, what's your impression about the opportunity?
I love the opportunity. At the end of the day, we're still using and procuring 100 million lead acid batteries, 12 volt, in the United States every year. I think that lithium technology is a great offset of that for second life applications. We're currently building battery packs for RVs and marine applications to replace electric motors, and to replace off-grid solar, and to replace lead acid forklift batteries. And so we found all these applications at bigbattery.com, and we've created in the last 18 months 26 different SKUs, 26 different battery packs in low voltage applications that are all recertified and repurposed batteries. And when you lower the application, you're able to extend the life of these batteries by setting the BMS properly. So we've been able to produce a total of 40,000 battery packs since the start of Big Battery, and it's just growing rapidly. In the last year, the company has grown 285%. We're picking up a lot more warehouses just to be able to handle manufacturing. And I'm just finding that there's a wonderful opportunity for us to bridge the gap between lead acid and lithium ion by taking these batteries and repurposing them in second life applications.
Yeah, very interesting. I was in a Reman conference a couple weeks ago, and they were talking about the question I asked to the speaker was, why did we start with leaded recycling, right? And the point was, in the beginning of the battery development, lead was hard to find, kind of similar to what we have with the new batteries. And it was recycling was the only way to be able to continue to make new leaded batteries, right? So I completely see, the whole repurposing and recycling. So Mark, you're covering everything, right? You're seeing the world through your editor lens. What's your opinion then on the opportunity?
Well, I think the opportunity for me is, if you get down to the basics, if it turns, that could probably be remanufactured. So any part on the vehicle, whatever iteration we come up with, if it turns, if current goes through it, if it's the battery, those things will all find a way to remanufacture it or repurpose or reuse it. One of the things that struck me in Munich was that very quickly vehicles are being seen as not just something to get me from point A to B. And they're loading the vehicles, mostly right now at this point, they're prototype vehicles, but many of them are starting to go into production. There's sort of this idea that they'll become rolling offices. And those, to Eric's point, when he mentioned early on, they're rolling laptops. They really are. They have a big battery, and the screens are getting increasingly larger. So could you pull the screen out of a car and use it in your home? I don't know, but probably. I mean, a lot of this technology is going to be used for possibly office work, entertainment. It already is used for entertainment, but a lot of the vehicles, especially as they go more autonomous and have less driver input, I just think that there are opportunities to load these things up with components that could be later be pulled out and repurposed. So I'm interested in the next part of the battery. Like I'm not a battery expert. I use them every day, like everybody else, but I keep hearing about solid state batteries, and I was kind of interested in the possibility that those may solve problems that we're currently encountering with lithium ion and every other battery. So maybe some of the other panelists can kind of touch on that later. But just as soon as we're talking about lithium ion and those purposes, what they can be used for and how we can reuse them, and then solid state and everything kind of, it's changing as it's changing. So there are any number of parts in a current ICE vehicle that can be remanufactured. And to some extent, there are partners in the EV that can be reused. And that there is going to be less remanufacturing opportunities, obviously, because there are many fewer parts in the powertrain of an EV. So while on one hand, it simplifies the whole thing, it gets a little more complicated because you have to be kind of strategic, because there's not going to be as much to deal with. It goes more to like electronic content in the vehicle.
I get the impression, if you look at it from a low-hanging fruit, which would be when I mentioned the cost. So the batteries everybody's going after because it's by far the most expensive, but the power electronics, maybe the drive motors, are opportunities. Again, they'll wear out. You can easily, the reman electrical or rotating market is huge. It's been around since the 50s. And you can see drive motors are just maybe a more complicated version of some of that technology. So I do see like some opportunities. I think what's been interesting, and I know, David, when we started seeing the original power electronics of the EV1, there was a lot of worriness about the survivability. And I've been impressed by actually how well the industry's done to protect itself, like the warranty cases aren't super huge, and I think even the power electronics and at Delphi, when we did the power electronics, they didn't really fail. And where I thought they would be huge opportunities in reman world, to be honest, they don't really fail. And they've been, obviously, that's the critical design efforts by the engineering people to look into that and make things work, because I think that nobody wanted a black eye, I'm going to go back to Mark. So a second part of this question of opportunities now is we've been talking about is automotive, and the automotive guys were first. But to be honest, I'm currently in the heavy duty market, and the heavy duty market's I think, quickly coming to maybe beat the auto guys. Mark, you see it from the perspective. I'm going to come back to you because from the perspective at maybe in Germany when you saw it. And I know that the Chinese are really into the heavy duty buses and stuff, but where do you see the opportunities of the heavy duty market compared to the auto industry?
Well, when I think heavy duty, I think everything's bigger. You kind of have to supersize everything. It's like the difference between a regular size coffee and a big gulp or something. The applications are certainly different. You're not carrying your family around. You are, I would think, obviously, your battery pack in a mining vehicle that you would use down in Chile is going to be monstrous in size. You probably don't have the problems that you have. I was just thinking along the lines of tires. You liked, Jeff, you mentioned liking driving the first time you drove an electric vehicle, and it was fun. Those can chew through tires because of the torque. You may not have that problem with the heavy duty vehicles. Maybe you are more focused on the task at hand. A lot of these a lot of the mining vehicles, they already have autonomous sort of diesel vehicles. So I think the creature comforts aspects, some of those things go away. So those may not be your opportunities in heavy duty. Certainly motors, definitely that would be an aspect of remanufacturing, because those things get such a workout. And mostly battery and motor and any sort of rotating components of the heavy duty. I just went to mining, but they have tested large, they're in the early stages of testing fleets on highways. And I saw that, and an example of that, that's just where my mind goes. They're ahead because there's a practical use case for heavy duty. If you can eke out more profit, you might be more inclined to do that. So that may be why heavy duty is seen, seen to be surging ahead a bit.
Couple of factors could come into play with heavy duty as well. When you think about it, from the automotive perspective, and I worked for an auto company, heavy duty vehicles, especially even Class 8 trucks, they're almost like hand built by comparison. So that makes remanufacturing that much easier. They're also million-mile vehicles. So you plan on rebuilding it many times during its life, which actually does also lend itself towards rebuilding the batteries and remanufacturing those components. When you look at buses, which are one of the largest applications, especially in China, but quickly coming to the US, those are centrally controlled and centrally managed. So you'll have that advantage as well. You'll have uniform batteries, uniform maintenance, and central repositories of how it works. So that'll drive remanufacturing in those areas as well. So those will give you some benefits. Now, on the negative side, you've got the fact that electrification right now in vehicles is proceeding, light-duty vehicles is proceeding quickly. In heavy-duty vehicles, you're going to be competing with hydrogen. You're still going to compete with diesels, which are extremely efficient. So you're going to have a much higher bar for that competition level. So it's kind of a give and take. On the one hand, once you electrify, I think you're right, remanufacturing and the battery recycling and battery reuse will be much, much easier. But it's going to be harder to get there because you're going to be competing with a lot of other new technologies as well.
Yeah, and I'd echo Don's points. I'd couch it in TCO, total cost of ownership. That's just a conversation that absolutely does not happen on the retail side. It's the sticker price. The sticker price drives everything. But in heavy duty and fleet, in those types of operations, total cost of ownership wins over everything. And so if you can explain that story, if you can say, yes, we're going to have this this vehicle, it might require some maintenance and you might have to replace some modules, so forth. But they're going to ask those questions and they're going to have their spreadsheets with all their line items filled out. And as soon as you have that story where that number is lower than your existing number, it's done. It's game over. That's the path forward. So I think that's absolutely right that medium heavy duty and commercial vehicle are going to be faster in a lot of ways. That being said, there's going to be some retraining. I think the past car companies do have a head start, at least a few of them. So my former employer, General Motors, is big on that. Tesla has their service centers, so there's potential for them to have a little bit of head start there. But I think as the economy shifts to electrification and to green jobs, that's going to be front and center, and heavy duty is going to be right there to take it up.
To Dave's point, when it comes to the sticker price, the economics are going to push for consumers to start using LFP batteries, lithium iron phosphate batteries, rather than your NMC or NCA batteries. So we're seeing that right now with a lot of the majors, VW, Ford. You have Tesla's new contract with BYD for the LFP batteries and the Teslas that are coming out of China and currently being shipped to Germany. The business case for LFP is growing. I'm watching as all of our factories around our facilities in China are all switching to LFP as just a low-cost leader to be able to drive this tsunami of EVs that need to be manufactured today.
Excellent. If you don't mind, when Mark mentioned solid-state batteries, looking at that's very exciting from the development of battery perspective. But from the recycling perspective, it's like, let's fix on a battery type so that we can put processes together. As we start to reach out to solid states, ceramics, sodium, magnesium, when you do that, that destroys the ability to do recycling, because we're going in so many different directions that we can't come up with a single process that allows, and then you have to hand do everything. So we want to automate it. We want to have process down. We want consistent battery materials, consistent chemistries. Choose one of them and go forward, and then we can get to the recycling space.
It's worse than that, Don. I mean, they can't even decide on if they need lithium hydroxide or lithium carbonate, and that's lithium. It's just lithium. Everything uses lithium, so that is a big problem. And as soon as you said solid state, I was looking to see if Don's face smirked as much as mine did, which it did. It was good to see. I think that's, for a Reman standpoint, that's exactly right. It's just another curveball to be thrown in. But it's also, 5 years minimum before you start seeing any sort of initial market penetration. It's very far out. And I think always the claim is like a solid state can solve all these different problems, which is true. If you have the solid state that solves this one, solid state that solves that one, there's one over here that solves this one. There's not one that solves it all. And unfortunately, when you looked at that initial price curve, from, was it 7,000 a kilowatt hour in 91, right, down to it's around 100 now these days. The chemistry has changed from LCO to NMC. Everything else, it's graphite anode. It's all been improvements. It's all been these incremental improvements. That price drop has not been because of step changes in brand new chemistries or solid state. It's been a lithium cathode with a graphite anode, and that continual cost down is going to be. We continue to drive this market and grow this market, and it's going to keep bringing the price down. And so that's why solid state, it's fun to talk about, but when you look at what lithium has done on its own with the limited changes and just design tweaks throughout, there's a long runway for what we have today.
This is kind of a good lead into kind of my second question. Now, you guys are mentioning different designs and maybe the challenges because there's really not a standardization, so to speak. And so I guess the question is, so going back to understanding the remanufacturing, repurposing world, is this the evolutionary leap? Is it time for these guys to get into it? Obviously, Eric, you're in it already. You've been in it.
Yeah.
I mean, is it time for the reman guys to say, time's come? At 2035, 50% of all the brand new vehicles are going to be EVs, and the time, is the time coming? So maybe, Eric, you could start with that. And the question is all the different challenges, right? What are those?
Well, the lack of standardization is a big issue right now that we face. Every pack that comes in, even from a single OEM, they have their Gen 1, Gen 2, Gen 3, and they're always changing, right? We're seeing large recalls, the largest in automotive history. We're seeing packs that are coming out of Shenzhen, specifically all the BYD buses and taxis we do in Shenzhen. They all use LFP, but then in the United States, we're all stuck on NMC and NCA. And you got your prismatic and your cylindrical and your Chemcell and it's insane when we open these packs, the amount of R&D that we've had to do just to be able to standardize some of this in the products that we're building. The repurposing of new products require a format of standardization that we've been able to figure out through our IP and using specific types of BMSs and thermal management systems and case structures for our modules. So long story short, I think this is going to move in the direction of standardization that we saw for computer electronics in the 90s, where it used to be that there was 20 different LCD manufacturers, and now there's 3, right? And there used to be 14 different NAND flash manufacturers, and now there's 4. So once we get to that point, I believe the skateboard technology that a lot of companies are using will become standardized. We're seeing certain prismatic cells become standardized today, and OEMs are using the same prismatic cells from the top 3 manufacturers. So that's really helping. But today it's a hard process. In the future, it's going to get a lot easier, and I hope that more people start practicing repurposing as it gets easier, and I hope we can pave the way.
Yeah, that's really interesting. David, your comments on that?
Yeah, I would say that's kind of the antithesis of what OEMs want to hear is standardization. You know, how do you differentiate? It's you have something different. You have a unique chemistry. You have a unique thermal system. You have something that's interesting. And while there is aspects of it, maybe the cell format that you can start to standardize, there's always going to be a need and a desire to have something unique. And the more you standardize the most expensive component of a car, the fewer opportunities there are for that. So I think there's going to be a push and a pull in what is standardized and what is allowed for you know, some level of uniqueness. But the cell formats, when we look at the projections and we look at the automakers, what they're doing, it's still not clear, you know, what the future is going to be. And regardless of a standard that does come out, we don't know what that is today. And unfortunately, we've got to deal with that in, you know, 5-10 years when these cores start to pile up.
I mean,
so
I'm sorry.
Yeah. It's just going to be interesting to, we can wait on standardization, but we have to act now and we have to design those systems now. So it's going to be a while before it's going to settle out. Go ahead, Don.
Yeah, and not to contradict myself, but at the same time, there's still so much improvement that we're making in the batteries as we go forward, and it's hard to leave that on the table. You know, we want to get cobalt out because cobalt's the high cost and the big problem. We want to get nickel out if we can, because we're limited in nickel and cobalt supplies. We can continue to get better efficiency and drop our costs. You know, the cathode is kind of the key to all of this, as you keep getting better and better cathodes for recycling and also for the improvements. So on the one hand, we want standardization. Let's stop where we are and just do it. But then we lock in 10-year-old technology instead of going forward. And, you know, there's this 10-year lead on everything that we're going to be recycling, because it's going to be constantly changing and updating. And you don't want to stop doing that at the same time. So it's a real dilemma. How do you lock in on a good chemistry that's going to be broad enough that you want to have processes and invest money to put machines in place to recycle that and hope that that one's going to last for multiple years.
That's exactly right.
Yeah, it's a real dilemma. You know, you could go with lithium phosphate. That's an old technology, and it's not in the U.S. extensively. And you really want to push to the next levels. You want to go to NMC. You want to go to some of the low cobalt chemistries. And solid state, we'd love to get there. So,
to your point, Don, you know, LFP doesn't have cobalt and doesn't have nickel, and you know, iron is pretty. It's everywhere, and phosphate, and the amount of lithium, the reserves on lithium are good. So it's not only cheaper, but it's also a prevalent source that we can mass produce. I would love to see the standardization of the actual form factor, not the chemistry, but the form factors, so that way we could be able to extract cells easier, recycle cells easier, and then repurpose cells easier as well. What we're going to find, though, is that as we move to these newer battery chemistries, we're going to find that they're manufactured using cheaper commodities, which means that on the backside, our scrap recyclers go from paying 75 cents a pound to charging 75 cents a pound. And when that happens, the only solution that makes sense is to have second life prior to scrap recycling. Otherwise, all this product will become low-value e-waste. It will go in the same direction as low-value e-waste, which is exported and recycled at less than 13% per volume capita in the United States. So, I mean, I would love to see us process the material in the United States, practice second life, and that would offset the proper cost for scrap recycling as we switch to the batteries that have nothing to extract, nothing of value.
Keeping the batteries in the U.S. is going to be one of the biggest problems as we go forward. It's so simple to ship them overseas where they're currently manufacturing them and remake them there. That doesn't help the U.S. That doesn't solve our problem. David, you mentioned a little bit about you know, the automakers competing with each other. And honest question, you know, when you look at auto companies, the thing that differentiates them is their engine, almost always. Mm-hmm. Is that going to be the battery and the power electronics, or the drive system, or is that going to change to something else? I'm curious.
It is. So right now, when you look at EVs, the biggest, so let's talk past car for a minute, but when you look at the things that are the big ticket items on an EV, it's range, it's not efficiency, but efficiency falls into all the other ones. So it's power, it's performance, and so forth. The battery is central to all of those. And so while you might not have the same recognition of, a Chevy small block, they're not necessarily going to know exactly the chemistry. They're going to know a Tesla battery pack does X, Y, and Z. They're going to know a VW battery pack does X, Y, and Z. And so it's going to be central to that. And past cars, they don't really want to let go of that for obvious reasons. Now, in the future, when things become more standardized, when it really gets settled on, is LFP going to have the energy density long term in order to compete with a sufficient level of NMC, those types of things. Some of that will be standardized. I mean, let's be real. Does anyone care what their old Chevy Sonic engine was? No. So there's going to be large swaths of the market that it's not going to be differentiating, but a BMW and a Porsche obviously are never going to settle for that, and even it's certainly not a Tesla. So they're very concerned about that, and there are system level things that can be done, but so much of it comes back to the battery that it has to be there. Charge time is probably the other big thing that is really critical, and that's something that's really going to turn the page for folks. I think there was a comment recently, or some research recently. Everyone was range anxiety was the big term.
Right.
It's now charge time anxiety. I can't remember what they called it, but everyone's like, okay, well, I'm sure I can get somewhere, but in order to do that, I got to wait half an hour to fill up. That's nonsense. So
and that's the new research we're doing.
Yeah. There's plenty of those steps that need to be solved. That are going to rely on those new chemistries, those new design formats for the battery, the thermal design, that are going to really matter. When it comes to maybe heavy duty and some of these larger ones, I think there's something to be said to that as well. Again, it's much more of a dollars and cents calculation. So whatever you can do to make that number work, I think is more important than necessarily, saying your battery can set lap times. That just doesn't really matter. But it's still going to be important, and you got to hit those numbers. If you're the one that can hit the numbers, then you get the gold.
That's true for heavy duty. In some cases, they're all using the same engine, but then why does Cummins and other engine companies exist? And that's because of their capability and specialty in that. So you're right. It's nuanced.
Yeah, I think, Don, you brought up a good point on this whole thing, and I think, Mark, from your Intel side, how are these companies? I mean, again, is it range? Is it 0 to 60? Is it what's going to differentiate like one battery or powertrain from another? What do you see?
The thing that I saw in Munich was style. It seemed to me style and use became more important to sort of the PR pitch of a lot of these vehicles and what you could do once you get in them and the entertainment options. I don't recall hearing too many 0s to 60s, but it's definitely just sort of, nobody buys a Tesla. When people buy a Tesla, it's because it's got a certain style to it, and that's just the way it is. And it's kind of the same reason people buy an iPhone over something else. And so I think that's kind of where it is. I didn't hear a lot of talk about much else than look how pretty this thing is. I mean, it's, and by the way, it doesn't hurt anything when you drive it. And yes, it does charge fast, and you can use a fast charger. So I think it's a lot about style. It's just the feeling that it gives you. That's kind of what the car companies seem to be pitching, and I'm fine with that. I mean, I would like to go someplace in style and look good. So I think that's probably what a lot of people are concerned with. The one question you asked earlier about challenges to reman EV batteries, I was going to ask Eric. I get a lot of press releases as a journalist, and recently what has started to come through is lifts that are used to lift the very large batteries out of vehicles. And the Tesla S has what, a 1,200-pound battery or something like this. It's really large battery. So my question is, and Jeff, you asked this, what are some of the challenges? You asked about the actual remanufacturing process. And I'm thinking from the standpoint of the automotive aftermarket, what's it like to get a 1,200-pound battery? I'm struggling to think of anything other than an engine that weighs that much on a vehicle. So Eric, if there are people thinking about getting into reman of batteries and these large components, like what does that look like? I mean, we have to get them to you somehow from the shop if they're going to put a new one in. So how does the automotive aftermarket take that battery out and get it to you? What does that look like?
Well, today we are working with half of the auto OEMs in the United States. One of them we're picking up 30,000 modules from. They decided to do the demand at their facility. We send a 30-gallon steel drum with perlite solution. It goes to their facility. They fill it with one module, send it back, and we just keep repurposing that drum. But other OEMs actually just we pick up. I'm spending a fortune in reverse logistics currently, specifically due to the factor that it's all hazmat material and it needs to be packed a certain way and it needs to be in a certain container, right, to a certain UN standard. So when we get those packs in, it's a lot of work. The packs range from some packs are just the 0 to 5 mile starters. They're about 50 pounds, and then they go all the way up to, like you said, 1,200. And that Tesla pack that you mentioned had 6,700 of these cells right here. This is a 21700. Tesla actually, we got 47 containers of Tesla packs, and we turn them back into these cells that you see right here. And we repurpose these. You can see them in the city of Pasadena's electric lawnmowers. They're riding lawnmowers. You can see them in all the golf carts doing papa wheelies on YouTube. So yeah, it's a difficult challenge, especially when you're dealing with these smaller cylindrical cells. This is like super gluing a bunch of toothpicks to make a telephone pole. It just doesn't make sense. And what we're finding is that the future, this is what Tesla's using in the future right here. This is the BYD razor cell, real thin, first cell that you can puncture without thermal runaway. And this cell right here is basically, it's much less of these cells. This is LFP, and this is your BYD that's currently going in the Model 3s and Model Ys in China. So yeah, it's all different. My biggest concern today is the fact that we lack automation in the demand process, specifically when removing the initial bus bar to lower from high voltage to low voltage. And we have witnessed the effects of grounding out a high voltage battery pack here, and it's fireworks. So knock on wood, no fires to date, and we have produced over 40,000 packs. But it's definitely a process that I'd like to open source so that anybody that is willing to do it in the United States can learn from our experience. And hopefully we can have more of these Second Life facilities across the country.
I mean,
No, that's a great
to really go forward on this, I mean, you're going to have to go spoke and hub eventually to make it work just in terms of transport. But you really need tools that can evaluate all the different aspects of this so you can optimize. Because there are going to be aspects of cost, energy, water use, SOC emissions, greenhouse gas emissions, the byproducts and what the byproducts are going to look like. You've kind of got to factor all those variables together and build a tool that allows you to figure out what is the best way to make all these things work together. Because right now, because there are so few batteries, you're figuring out the best process based on what you see. But coming down, you've got to factor in life cycle, the whole aspect of what the impact is, including transportation and shipping and the environmental impacts. That way you can really figure out what's the best way to go forward. And I think, Eric, you'll get there. It's a matter of you're making money on it right now, so you're already there. But it's a matter of having the right tools and automation in place so you truly are optimizing it and not doing harm someplace.
Well, Don, let me tell you why making money is so important. If we don't have a business case that's profitable, then it's not sustainable.
Right.
I don't want the government involved. I don't need some, aggregation system that taxpayers pay for. What I would like to see is the value within that battery, the reusable value, the utilitarian value, offset the cost of proper recycling in the United States, and everything kept in this country.
That's right.
And to employ people in this country and to have batteries where currently supply's not going to hit demand until 2040, 2050. So what are we doing until then? Are we begging China for more, or are we repurposing what we already have? And your hub and spoke that you talk about, that's a coined phrase from Li-Cycle, which is a very well-known company that's gone public recently. When you speak to Li-Cycle and you say, what is your solution for the new batteries coming out? All the ones that don't have any commodity value, and their solution is that they're going to charge. They have to. And the question is, who's going to flip the bill? Without Second Life, nobody's flipping that bill. I've never seen a federal mandate in the United States for recycling. I've seen statewide mandates like SB 20 in the state of California for CRT monitors and LCDs, but not for batteries and not on a national level. So how can we build a business case that will allow for an efficient process and sustainability within the United States? That's what I'm concerned about.
You've got to get industry buy-in up front for design for disassembly. And that's what this is all about, is talking to the manufacturers before they build those batteries, so that we're not figuring out afterwards, but it's designed to go forward. And you're right, this is from the US perspective. I work for a US lab. We want to keep this in, we want to move those jobs here, we want to move the manufacturing here, we want to make sure that cycle is contained within the United States. It's extremely important to stay here for a lot of reasons, not just for the cost. So yeah, I think we're both on the same page.
So we are the only company in the United States that goes to OEMs and says, we'll pay you, and we'll cover all logistics, and we'll write you $1 million checks instead of sending you bills. And they say, well, are you R2 certified? Do you have downstream? Can you show us where every single one of the parts and components goes? Are you willing to destroy everything that's proprietary and only reuse or repurpose the generic parts? And can we separate our liability from these generic parts? And we go through the whole process with them. We've been doing it for 6 years. And once you once you appease the lawyers and you move to the CFO, it's a shoo-in. These companies are not prepared to pay for the cost of reverse logistics, aggregation, triage, proper recycling of product that has no intrinsic value other than utilitarian.
I'm going to pull a question from our audience related to, we've been talking about moving these big batteries around, the 1,200 pound batteries. So obviously storage and warehousing is a big issue. And Eric, you obviously deal with this, and David, I'm sure you have a familiarity with this, is how does storage deal with the second life? And then when is there a point says they're not worth it anymore?
Yeah, just real quickly, because I know Eric will probably have more to say on this, is the storage of batteries is different than a lot of the other reman components that we're familiar with in this space. And I know we talked about some other components, motors and power electronics, and those will have their place, and those will be more standardized and familiar. But batteries require unique settings because they are hazmat, because they're large, they're bulky. They have to be kept at the right temperature and humidity. You can't be corroding these things, and you can't be storing them at 60 C. That's very, very bad. So they have unique opportunities. And I think to Eric's point earlier, and I've always said this, is I don't think reman for batteries is a technical issue. I think it's a logistics issue. I think number one, it's a logistics issue. Once that's solved, once the market is clear, once those questions are solved, whether it's pyro or hydro, you're going to do a little bit both. You'll tweak, you'll balance it out. We have the technology to do a lot of this stuff, but it's getting the logistics, and it's getting all the players involved up front. And I think that's a big part of it. So maybe Eric, I don't know if you want to follow up on that.
Sure. So to David's point, the major issues when it comes to storage that we're facing, just trying to get insurance. I could be insured by Lloyd's of London for $18 million per facility just for environmental coverage. When this product comes in, the way that you actually handle the product we have fireproof zones that are just pure cement. The product must stay there indoors before moving to the main facility, and it must be repacked. A lot of our OEMs send us product that is not packed correctly, where the leads are not actually taped, and where the product itself, they're just loose in Gaylord boxes. And we wonder why all of these waste management facilities are having fires, and why all these other e-waste recyclers around the country are having fires. And it's because they're just not equipped or well educated to deal with how you're supposed to properly store these batteries. As David said, they come in all different conditions. I mean, some of these are brand new, and other batteries have gone through extensive vehicle testings or been in accidents, auto accidents. So it's very important, the process in which you deal with the product, and to make sure that all of the batteries that are brought in-house are packed in a certain format where the leads can never touch and you'll never have to experience thermal runaway. We bring in the fire department in all of our facilities. It's usually 2 to 3 weeks. They just come in, and I ask them every time, is there anything we could be doing differently? And at the end of the day, if you have an NMC fire, that cobalt is creating oxygen. So you can throw that battery underwater and it's still going to burn. Luckily, we've been able to, with our LFP batteries, incorporate fire extinguishers in every single one of our packs. It's a technology that BYD uses today, and it will actually suppress 1 cubic meter of airspace to be able to eliminate a fire within the packs that we manufacture. But it would be great to see in the future some format of standardization in the aggregation process as well. When you look at e-waste, this stuff here can still go in your trash can, right, from a consumer. But due to the sheer size of these batteries, waste management will not be aggregating these. They will be aggregated by the auto OEMs and repair shops, and a lot of these are finding their ways into the junkyards, at some point they're going to be extracted and need to be sent to guys like us and then sent downstream to scrap recyclers.
And remember, the only way this works on the other side is that we need to increase energy density of the batteries more and more to make them competitive with ICEs, which means your problem gets worse and worse as we pack more and more, energy density, power density, pack more and more electrons into smaller spaces till we approach the energy density of gasoline, which highlights even more of the problems that you're going to deal with. But that's what brings more efficiency, better performance, and then on the recharge side, certain chemistries are great for fast recharge, but that also can make them less stable in some situations too.
Don, you're correct. It's energy density, but it's also the cost per kilowatt hour.
Yes.
And the consumer is only worried about the cost per kilowatt hour. And as we try to build these small hatchbacks that are going to be, for mass adoption of electric vehicles in the United States, or cheaper vehicles, we're going to find that the range is less important in those applications. People will be happy with the 2 to 250 mile range. And not need the Tesla Cybertruck's 500-mile range, right? So I see a place for LFP, but I understand what you're saying. And no matter what that future chemistry would be, I believe that it will be manufactured using the closest materials to dirt that we can find, right, which means that these scrap recycling solutions that we have today will not suffice without Second Life.
Sodium.
Yep.
So going back to the question from the audience again, and it's interesting, as you guys know, about the chip shortage issues. Obviously, it's confounding everybody. And the people that are into the remanufacturing of circuit boards, printed circuit boards, things like that. Is there a relationship between remanufacturing electronics and remanufacturing batteries? Are they related? Is there an issue with maybe material shortage, or that may be more on the recycling side or the reuse side, or what do you think? Who wants to start with that?
Maybe just real quick, I'd say there's a lot of differences between the two. You can airship a bunch of scrap electronics if you needed to. You can't do that. You can't airship a new pack without considerable expense. So they have very different front ends around that. Does it relate to material shortage? Silicon is generally pretty cheap. And so it's really about the value add of making that into the chip and being the right chip. I think a lot of the shortages that were caused in the automotive industry because of chip shortages is not good planning. We did not realize how razor thin the margins were not from a economic standpoint, but from just a general stability standpoint. The supply chain is, because if you put your order in and it comes in when it says it's going to come in, I'm fine. Who cares? But no one had the foresight to everyone step back and look at the whole system and say, guys, if we don't do this just right, this could really throw things off. So I think that has shocked a lot of, especially in the automotive world, a lot of folks into reassessing that and reassessing their upstream supply chain. But it's I think they're different causes. I like Derek's use of the word dirt. Everything comes from dirt. We don't realize that at the end of the day, but so much of everything we have starts out as dirt and sunlight, I guess. But I think we're now looking at the upstream. The amount of battery production is expected to far exceed the demand, if you account for all of the PowerPoint presentations that say they are. Not so much of the actual production that's going to happen. So we're paying more attention to it. We're looking at how we can leverage all of the necessary supply chains and supply streams to handle that. Recycling is going to be very critical for batteries, but it's going to be a while before we get there. We're in a process of trying to ramp up, and in exponential growth, the recycling is only going to be a marginal benefit. So it goes to Eric's point that second life is going to be important. That only defers the ultimate recycling, but it's going to be important. And in 10, 20 years, once we've had those conversations and talked to those suppliers of all the materials and have those supply chains set up, then we're going to be much better protected. But it's going to take 10 years before that protection starts to make dividends.
It's what's interesting what you're saying, and maybe this going to go and kind of lead into my next question, and probably start with Eric on the answer to this, is maybe the issue is education of the public about this reuse, right? This second life. I can understand if the OEs are working on ways to reduce their warranty costs, and they're just going to repair, refurbish the batteries and go right back into their vehicles, right? But those are for batteries that kind of maybe didn't really run their first life right? This whole remanufacture, repurposing, and reusing is, I think most people have no idea that Eric's had these batteries that he's developed for the RV industry or whatever. As an RV owner, now I'm really interested, right? So I'm about ready to replace my deep draw cell batteries, right? How do we work together, to create and maybe educate the public on this second life? What do you think, Eric? What's the solution?
Sorry, I was on mute. Well, I think the solution would be, first and foremost, when you show the business case to a consumer, the price per kilowatt hour at $200 a kilowatt hour for a finished product in the United States, for example, then they compare that to lead acid, and they see that their lead acid batteries in a golf cart last 2.5 years, and these are guaranteed to last 10 years in that application. So it's showing the business case to consumers is how we're going to be able to really. Marketing is less important. It's a lot of our business is now coming from word of mouth. We are doing about 1.6 million to B2C online every single month through one of our sites, all Second Life repurposed modules. And so anybody who says, well, there's no business case for Second Life reuse, please come talk to me. There is, and I'd like to see more people do it. But then we've also found a lot of success with B2Bs. I can't mention a lot of them, but we are providing a certain cell, specifically this cell right here that you see. These are going in our Rhinos. Battery Evo is our brand. So those are going in our Rhinos, and it's a 22-year battery. that utilizes the same cell that Tesla's using in China. And that unit is at a price point that's 2/3 the price of Tesla, and you get 2 kilowatt hours more worth of capacity. It's the thinnest Powerwall in the world, and they're here ready in the United States. Now, how can we afford to do something like that? Well, it's all about creating a better mousetrap, right? We're not building a $2 billion facility to mass produce a cell that we're stuck to. We're reintegrating all of the surplus cells that other manufacturers procure and then don't use. For example, A123, when they were purchased and procured by Lundgren, we got in 40,000 cells. When NEC just got bought out, we got in 36,000 cells, all brand new in crates that were literally going to be sent downstream to a scrap commodity recycler. And to me, that's a format of electronic abortion. I don't really care about the cell itself. I care about what it can do for humanity. What could it do for you, Jeffrey, if I put that cell in your RV, right? And if it lasted for 10 years and there was zero maintenance, and you could drive that thing in crazy temperatures, and just all the benefits of the less weight and the fuel efficiency. And there's so many benefits to reuse. I would just like to see more of it. I like to use a very simple analogy. This is my thermos. I've used it for 7 years. It's metal. I'm not going to shred it down for commodity value until it stops working, right? But it still works as a thermos. So that's our batteries today. There will be a time in which we need to actually properly downstream scrap recycle these batteries to close the loop, right? But the only way that that's going to make sense in the United States is if we can figure out how to reintegrate these into new applications like storage. So another example, we're working with Netflix, and we're doing a lot of work with them we built 147 solar power trailers over the last 18 months, and they're using those on their off-grid movie sites currently in Arizona and Nevada. We're working with one of the largest electric truck companies to provide batteries for their supercharging fleet. We're working with some of the major logistics carriers. We are reintegrating Second Life batteries in emergency applications. And last year, we powered, you can see it online, 12 hospitals for the COVID triage centers using Second Life batteries from the Chrysler Pacifica, the PHEV. So there's a lot of different applications, and the world needs these batteries. And as long as there's life in them, we're going to put them back to use.
So Mark, from an editor standpoint, how do you get the word out? Although you may be ratting out the auto industry. So how do you deal with that?
I think it's all a really very easy sell for the modern consumer. The modern consumer wants experience, so they buy experiences. And then when they buy things more now than ever, they want to know that they're doing good things with the things they buy. And they are in large part the reason why you go into a lot of grocery stores in a lot of states and you can't get a plastic bag anymore. You have to buy a recyclable bag. And I think they'll feel the same sort of way about electric vehicles in that respect. If they know, like Eric said, that that the battery in their car is going to go someplace and do good things, I think that speaks to them more now, because people don't want to waste stuff anymore. They want to find another use for it. And one of the things that happened in 2011 when there was an earthquake in Japan, Nissan sent this was years ago, 10 years ago now. They had a major earthquake in Japan, and they sent a large fleet of electric vehicles up there, and they used those to power for emergency power. They were plugged in. And so that's another use for something. It's a good use for something that we normally wouldn't use. And I think the story kind of tells itself. The more of those instances where you can say, hey, I have a home backup battery now that used to be in a car. People like that kind of thing. They don't want to just hear that things go in a landfill and they never get used again. So the story kind of sells itself as far as I'm concerned.
Interesting. Nah, really good point. I have a completely different thought on that whole thing. And I think that people that buy electric vehicles, maybe that's an interesting conversation, is that they know when they buy this, it isn't going to maybe damage the earth if we deal with the end of life, right? And have a good reuse profile or process. So yeah, that's pretty cool. Maybe just the final, we're running out of time. We have another 5 minutes. I want to talk a little bit about, and we've touched about it, but so how do we get together either standards or something related to the design for either reman or refurbish on batteries? I mean, how do we, I don't see a lot of SAE like specifications, they like on the ICE world, and maybe because I'm not really old enough to know when engines first started in the 1900s, there wasn't really any maybe standards right now. And I feel like we're the same way. Everybody's just kind of running around trying to get the best deal. Is it going to take standards to help on the design for reman, refurbish? What do you think? Don, you want to start maybe?
Yeah, sure. I was president of SAE for a year, so I know that.
Yeah, I forgot about that. Yes.
That we were engaged in as well. It's going to take the engineering organizations, but it's also going to take pre-competitive work to really make this happen within certain industries. Obviously, I work for Department of Energy, and they have this activity for a recycling center, and the idea is to bring in the main users and figure out what pre-competitive parts of this do we really need to solve so that we can have processes that'll work. Bring the auto companies together, domestically first, then internationally, and talk about what can we do outside the competitive space to make sure that we have common chemistries, common methods of disassembly, common uses for things, so that we realize there are areas. David's pointed to some of the facts that there are competitions between them, but there are a lot of aspects of this that aren't competitive. Well, what things can we get together and put together industry standards that allow us to build them up front so that we can get the end that we want? And part of that is there are pre-competitive activities. There's U.S. car, there are the auto industry combinations, and then there's Department of Energy and the national lab activities to look at and do life cycle analysis and do key pieces of this to make sure that these things can be designed so that the standards are uniform. And ultimately, regulators will take it from there. But up front, you've got to begin doing research before the regulators get to it.
And I think it's important, the guidelines and so forth are going to be critical. So even if they're not standards, having the guidelines available that everyone can see. And maybe this goes back to education, and it's a little easier to educate OEMs because they speak in dollars and cents. But educating them on refurbishment. I think that's going to be very important, because the same activities that you need to do to make sure your pack can be put back in a vehicle at the lowest possible cost, those are the same activities that they are then going to be used for repurposing and then eventually recycling. So educating the OEs on how they can make their pack refurbishable is going to do a lot, and whether it's standardized or not for repurposing, I think that's part of a next step. But even getting to that first step of refurbishment is going to be a big step forward, and that'll spark enough conversation then to say, like, okay, well, since we're in the middle of this, we're going to have to deal with these. And in Europe, it's legally mandated that the OEs are going to have to deal with this. So what are we going to do to make sure that's as cheap as possible as well? Not just cheap to put it back in a vehicle, but cheap for us to get rid of it and move it on to the next downstream use. So I think there's plenty of market solutions out there, but in almost all cases, the logistics aspects of it, the design aspects of it, so many of these, right. It's about getting everyone at the table and having that conversation now. The sooner we have that conversation, the more likely it is we're going to be successful. We've been given the keys to drive. Electrification is here. That question is no longer a question. It's a statement. Now it's our job to make sure we don't wreck the car.
Eric, if I went to you and said, give me your top 10 peeves, you would give me this list, and to throw it into these guys, say, here's the problems I see, right? You're touching it, you're at the end, and how do we get everybody together? I appreciate that there's not a ton of over-regulation here, which could, I think, screw things up, and we're letting kind of the market drive a lot of stuff, but you're the end user. I think they start with your issues and work it back, to help work together somehow,
The biggest issue that I'm facing right now is education. A lot of the OEMs are partnering with scrap recyclers and investing in scrap recyclers. You got Ford with J.B. Straubel's company, right? You got Redwood. You got GM working with Li-Cycle, and all of these standard old school recyclers are just stuck on, we're going to destroy the battery and we're going to try to extract as the commodity value. And here's the truth. Here's what we know. We know that cycle life is going to increase, and we know that the commodity value is going to decrease in future batteries. And so we know that the old school solution will not work. We need to be innovative. We need to outthink this problem and create a solution that's sustainable. It amazes me to know that Tesla, the largest manufacturer and the largest consumer of lithium-ion batteries in the world, refuses to practice Second Life. We quantified it. It's worth $47 million a year if they just practice Second Life just at their Gigafactory in Sparks, Nevada.
It has
And instead,
twice the value per pound if you go to direct recycling. Just what you're saying, it has twice the value.
Wow.
Yeah.
That's interesting. Yeah. We'll have Mark shame him. But that's sometimes what it takes. And it is interesting because, they weren't auto guys, right? So they created a battery pack that looks like a computer battery, right? A laptop, because the cylindrical cells are the most unrepairable designs because they weren't auto guys. And it is interesting. So maybe there needs to be, some public influence on that. I think, especially if the word gets out. I think it's interesting. So I tell you guys, I need to wrap this to a close. I really appreciate it. I think it's been a great discussion. We have a lot of comments here about what a great panel. And it's beyond, I've had enjoyment just kind of moderating this, getting your opinions. It's changed even my opinion in the last hour and a quarter on, I really hope for reuse and repurpose. I coming into this thing, I was thinking that recycling was the idea, but I don't want to recycle before I get all the value out of it and all the reuse side. So I appreciate the comments from the coast here. So thank you very much. I appreciate it. And I really look forward to talking to you guys in the future. Eric, I'm going to talk to you about my RV. I'm really intrigued now. So awesome. Well, thank you very much.
Thank you for having me.
Thanks. It was a real pleasure.